Okay, now get some other roots besides just square roots, but just a quick review for square roots. For example, I know you know that the square root of 4 is equal to 2 because 2 squared is equal to 4. That's part of the definition of the square root. For example, cube roots, fourth roots, I know you've been exposed to them. You probably have not worked with them a lot. But for example, the cube root of, say, 8 is equal to 2. And the reason for that is because when you cube 2, you get 8. Similarly, the fourth root of, say, 81 is equal to 3. And that's because if you take 3 and raise it to the fourth power, you get 81. One thing with some of the other roots is sometimes be negative. With square root, you're always going to get a positive number out of it. But sometimes, for example, an cube root, fifth root, and so on, you can get negative numbers. As an example, the cube root of negative 27 is actually negative 3. That's because negative 3 to the third power is equal to negative 27. Let's take the fourth root of 16. Okay, that is equal to 2 because 2 to the fourth is 16. Because if you take negative 2 and raise it to the fourth power, you also get 16. Part is that if you take a fourth root, even number roots, 4, 6, 8, and so on, you get a positive number, either positive or negative. Let's take the checkpoint 8 and look at some actual work with roots. Okay, there's a the for works for square roots also works for cube roots. So for example, the cube root of 40, we could split that into two different factors. I would look for any factor of 40 that we can take the cube root of. The numbers you can take cube roots of are numbers like 8, because 8 cubed is, 2 cubed is 8. 27, because 3 cubed is 27. 4 cubed is 64, so 64 would be a number you look for, and so on. 8 is a factor, so I write this to start with as a cube root of 8 times 5, and then you can divide it, because this product works with cube roots, just like square roots, into the product. Actually, I should have written that with a separate root. Root of 8 times the cube root of 5. Then we can take the cube root of 8, which is 2. We can't take the cube root of 5, so we'll leave that one like that. And so that would be simplest form. Cube root of 40 is not form because it has to take the cube root of. So this would be the answer to that problem. 2 times the cube root of 5 is in simplest form. You can put the products back and then work with them. So this one, you can't, 8 does not root. There's no integer that you can raise to the fifth power to get 8. Put them back together, we can actually find one. So let's put it under one radical sign. So this is the same as cube root of 8 times 8. The fifth root of 8 times 8, which is the fifth root of 64. Okay, now 4 that has root. And this, takes some practice with these, but I know that if I 2 to the fifth power, 32, so I'm going to take 32 as a factor of 64. So I'm going to write this as the fifth root of 32 times the fifth root of 2. You can take the fifth root of 32, which is just 2, so this will simplify 2 times the fifth root of 2. We took out 2 from this expression. can split it into the root of the numerator, the cube root of 125 in this case, over the root of the denominator, which would be the cube root of 27. The cube root of is 125. 125 is 5. 3 to the third is 27, so the cube root of 27 is 3. So this simplifies to 5 thirds.